Well, hello to Al, and welcome to our lesson on volumes of prisms and cylinders. This is actually a review of stuff that you learned last year. Today's learning goal: I can successfully determine the volume of prisms and cylinders when given real-world applications. Well, you are going to do a few real-world applications, but what we're going to go over with in this video is simply how to calculate the volume if you know what the shape is that you have. So these are both prisms. And this is a cylinder. Well, a cylinder is technically a prism too. It's what we call a circular prism because it has a circular face on it. And we're going to calculate all of these basically in the same way. We're going to find the area of one face and then multiply it by the height of the prism itself. Now for a rectangular prism, all that amounts to is finding the length times the width, finding the bottom of the box, and then multiplying by the height. So you just multiply those three things together, and it doesn't really matter what order they're in. Now this is a triangular prism, and the face of it is the triangle. Now the area of a triangle we find using base times height divided by 2, or a half of the base times the height. You'll see it written in a couple of different ways to find the area of the face. And then we just multiply by how long it is, this height of the prism. So if you take a look at this, what I wrote over here is actually embedded right in our formula there. You take a half times the base times the height, and then you multiply by the height of the prism. And this cylinder, again, the face of it is a circle, so we need the formula for circle, which is pi r squared, or pi times r, and it's embedded in this formula too, and then we just multiply it by the length of the prism. So now let's do a couple of examples here. This one is a rectangular prism, so we need our volume equals length times width times height. And I just wrote it length, width, height. There's an understood times in between those things. If you want to write out the times, by all means go right ahead. And the three things we're going to multiply here are 10 times 5 times 6. So 10 times 5 times 6. And we can multiply that in any order we want. 10 times 5 is 50, and then times 6 gives us 300. Now remember that since this is a three-dimensional object, our units have to be three-dimensional as well, so we have to give it a cubed on our unit, so we've got cubic inches, or inches cubed. Now down here we have a cylinder, and the cylinder volume is the surface of the face, which is a circle, so pi times r, and then we have to multiply by the height of the object, which in this case is 12, but we're going to multiply it by the height of the object, which we use a capital H for. So 3.14 times r, remember r is half the distance across, so that's going to be 5 since it says it's 10 all the way across, times 5 times the height, which is 12. Now let's just punch that into my calculator, and we're going to do 3.14 times 5 times 5 times 12. And the result is 942. So 942. Now again, we need the units, and our units here are centimeters, so we go centimeters, and it's in 3 dimensions, so it's centimeters cubed. And one more example. This is a triangular prism, and remember we have to find the area of the base, which is the triangle side. So we need to use volume equals 1/2 base times the height times the whole height of the prism. Now the base and the height here, this is only the triangle at the bottom or at the top, and you can see that they've given us the height on here. On a triangle, the height meets the base at a 90-degree angle. So what we need there is 1/2. The base is 9 centimeters on this, because if this is 9 centimeters here, then this is 9 centimeters over here. So that's a 9 centimeters. So 1/2 times 9 times 4 is the height of that triangle in there. And then the height here that we're given is the distance in between, like it's this distance here from one triangle to the other. Not this slant here. That's not what we want. Not this slant here. We want the distance from one triangle to the other. That's what we want for the big H. So from one triangle to the other, I'll just write that here. From triangle to triangle. And so in this, that's 6.1. Now, you might find it handy to remember that 1/2 is actually 0.5. So when you type all of these into the calculator, you can just use 0.5. And that's what I'm going to do here. Let's pull up the calculator. And we will clear it. And we have to put in this whole string of stuff. 0.5 times 9 times 4 times 6.1. And our answer is 109.8. So 109.8. And it's in centimeters, so our final answer is in centimeters, but since this is a three-dimensional object, we have to give it 3 dimensions, so it's cubed. And now you have a worksheet where you're going to calculate a whole bunch of these areas of or volume of shapes. And then there's a few word problems. Now, if you get hung up on the word problems, that's a good time to have a discussion with me in class. And that's the video for today.